Yeah, last class I was doing, okay, I just completed, please mind it. What exactly the receiver point of view? Receiver point of view, input will be the some capital X, X1, X2. That capital X in exhibition will consist of two pointer. Number one, that is input plus noises. That is, each input to the receiver will consist of input value, that is SI of 2 plus WJ. So what will have the receiver? Receiver will check SI of 2 is correct or not through the probability density function and noise. And noise is the variation is average is 0. Therefore, what exactly we have mentioned is the output of each E will be dependent upon the probability density function, which will be calculated locally by the receiver itself. Therefore, that equation absolutely mentioned is x of t is equal to what? This is the probability density function. Okay, very clear. Look back. Each output of the receiver, which are got from the transmitter via channel, will be analyzed with the help of the probability density function, where the noise is equal to affecting on the signal is equal to 0. It is because we have taken consideration channel is equal to additive wise not white Gaussian noise. That means average of the noise is always 0. That is the mean of the noises along the channel is 0, and variance of the noises, variance of the along the channel when the information only depends upon the spectral density of the noise, and henceforth noises will not be much contributed to the output of the signal, that is x of t. Now exactly we can say, okay, now at this point, now okay, so now let us take one more point, likelihood last but one, likelihood functions. Likelihood functions. See what exactly that. See, for example, the receiver, as I told you, mentioned this is a transmitter, the channel, that exactly receiver here. The receiver will calculate some probability functions. As I mentioned, look back, this is the equation, the output. Very clear, this is the final output, and this x of t is equal to only depends upon the probability density function of the this things. This function, this is the function averagely generated by the what? By the receiver, the transmitter channel. This is the generation. That means generation of this function should be same as the function or function generated with the transmitter in order to transmit. That means expectation of the function generation by the receiver should be of the functionality of the transmitter. So that means what function generated by the receiver should be the same, that is like of the same like of this. Such we call it as likelihood function. Please mind it. So whatever the function, okay, exactly should be a same of that. That means when the receiver start, when the receiver generated with the function, the probability density function, that is the one. How exactly the receiver check the probability density function, through which it is checked whether the information received is correct or perfect, should be same as the receiver. That means when it started from the receiver into the transmitter, and finally from this function we have to derive the information. That means exactly we mean to say, let us say if we are going to send a subset of a signal here from the transmitter, S1 of 2, S2 of 2, S3 of 3, all the information has to be retrieved from when you travel back from receiver to the source via system from the receiver, channel and transmitter point of view. That is exactly the function which we analyze. From the function of the receiver, we analyze in a reverse manner up to the transmitter and judging the capacity, judging whether the received information is perfect. Such kind of a function is also called as likelihood function. This is the function. Look back here. Absolutely, this is the function. Okay, exactly. This is the function. This is the function which study the given function in an inversion manner. Look back here, very exactly here, inversion manner. Look back here. This is the inversion manner with particular statistical output, which is given by L of theta bar x, f of x bar are the likelihood functions. Where fx theta, this is the observation density at a different order at the receiver function. So likelihood function is the function which is generated by the receiver. That is a probability density function in order to check the probability of receiving the energy, probability of the assigning the error is 0, like that. So that from the function we are analyzed from the receiver to the transmitter via channel to the transmitter. That is exactly we call it as likelihood. L of theta of dash is equal to f of x minus theta is likelihood function. Fx bar theta is equal to observation density different orders. I hope you got my point. So this is the function generated by the receiver from which we are going to analyze till the receiver in a reverse manner, so that I am able to encounter, I am able to receive the same information which I send at the transmitter. That is exactly called as the likelihood function. How much the function which matches at the fag end of the transmitter is called as likelihood function, and that will indicate whether the information received by the receiver is perfect or not. So that means likelihood function has been this theta bar x is equal to fx bar theta, f of x bar theta is equal to observation density of the different order at the receiver. Okay. So look back here, what really happens simple is that, look here, see this is x of t here out of t, see you know that. So that means what is the likelihood to be had? See, as I told you that x of t, that is output of the receiver output, is equal to what? Probability density function plus noise. Probability density function of the receive, probability density function generated by the receiver in order to check whether the received the information is correct, plus noise. So noise is, as we mentioned, on AWS channel, and this is the output signal at the receiver of this value. Okay, this must be equal to the what? Likelihood function, because likelihood function says that whatever the function is generated from the receiver, whatever the function is generated from the receiver point of view, it has to be delivered to the what exactly? Transmitter. From the transmitter point of view, okay, from the transmitter point of view, okay, exactly here. So that is the function, this is the probability density, it is the function from which from the receiver we are going to analyze the what you call in a reverse manner up to the transmitter. Therefore the likelihood function, as for the definition, it has to be equal to that. That is what exactly here the likelihood function, look back here, likelihood function at the receiver is equal to the probability density function at the receiver point of view. So L of mi is equal to fx of this. Okay, exactly. So look back, the likelihood function for AW channel is equal, clearly given here, L of mi, this is the function. Okay, exactly. You are going to, this is the, because some, look back here, the equation, what do we call it as? This is the term which has to be, this is the term which has to equal to likelihood, because this is the term which generated by the receiver function now to identify whether the received information is correct. This function is equal to what? This function is equal to likelihood functions. Okay, exactly. Likelihood function is given by this point of view. So this means this is like another form of the likelihood function is used in, that is called as the log likelihood function. Let me not talk about L of mi, L and N because not much used. So please mind it, log likelihood function is the one which absolutely, likelihood function is absolutely used by the it is for analyzing whatever the function generated by the receiver in order to calculate it, from which it start to analyze in a reverse manner with respect to the statistical aspect. Please manage the statistical aspect. That means it's going to analyze when the channel comes, mean and variation, when till that receiver charge. Once it's received, if the information, retrieved information from the fag end to the front end, if it is correct, and we can say that absolutely the information is served. That is exactly the likelihood function is equal to probability density function at the receiver, which is equal to this much value. Now let's go back. Optimum receiver using the coherent direction. Okay, exactly here. The optimum receiver coherent direction like this. One more thing, maximum local likelihood decoding. Look back. These are simple, these notes. I'm just telling what is required for understanding purpose. I will not code everything. I will not code. See, what is maximum likelihood likelihood decoding? That means how much. The main idea is to that probability of receiving the information. Probability of receiving the information should be 0. That is what the main criteria for a design of a communication system, especially design at the receiver. As we know that whatever the receiver absolutely comes, whatever the receiver will receive the input, that is equal to observation vector capital X, each will be small x1, x2, x3, x2, that each x1 will be what exactly? Si of 2 plus each one will be equated to the what? Input plus noise. Okay, input is equal to whatever the input is, this is a constant. Noise is exactly is equal to constant. From the constant, and only with the probability density function generated by locally at the receiver will identify whether the received information is correct. So how much best possibly we will get the max, how much possible signal of input signal is exactly okay, is exactly God. This is the maximum likelihood function. How much maximum decoding? That means whatever the information comes, the maximum probability of assignment will be almost is equal to 0. That means maximum of errorless is 0. We call it as maximum likelihood decoding. Please mind it. Maximum likelihood decoding is absolutely, it means that whatever the information comes, it will be analyzed. Whatever the information at the input of the receiver, that is absolutely observation vector. Okay, will be analyzed with the help of okay, exactly. Okay, whatever this maximum likelihood decoding is, that this is the condition is required. Coding the information, that means decoding the information in a perfect manner, that is exactly called maximum likelihood decoding. Basic. Okay, this is will be get exactly here, right? So this is all the condition. Look back here. This all very simple. Look back here. This is the information, as we know. Same info si of t here. Okay, exactly. Si of t will go to the each bias function. Each bias function multiplied will get back to the information. This will be added by some noise signals. This noise is absolutely 0. This will be decoded at the receiver. That is absolutely will get back to observation. Very shortly I'll getting. So look back here, the maximum condition, exactly likelihood condition is, okay, exactly here, look back here. See, as we know that we are, while how it's going to check by the receiver, look back here, see, there is x of t is equal to input plus noise. The noise is equal to 0. So noise has to be Gaussian distribution. When you plot in the Euclidean signal space, the noise cloud is exactly at this point. Okay. So that means somewhere around the information received is also a match here. Look back. We have plotted this. Look back. Out x of t, representation vector of x. Each look back. Representation of the observation vector x. Vector x is equal to input of the receiver, which is equal to what? X1 small capital X1 small capital X2, like that. So each X1, each element of the observation vector is the summation of the what? Input signal plus what exactly? Summation of the input signal. Okay, summation of the input signal plus noise. Noise is absolutely 0, which I have already proved it. So this is, look back here, this is the observation. Look back, when you plot how exactly I told you the identification, in reality it comes to here. Look back here, this is the observation vector, this is the input of the receiver, and this is, look back, this is exact, this is a figure where the noise is present. Somewhere around this received signal has to be there. This is this, okay, look back, this point is called as this is the input. This is a transmit signal. Yes, we call it as a transmit point or a message point, and this is the noise. This is the received signal. Received signal has to be input plus output the noise. So this is the point at which, when you combine with, we'll get back to this. This length will give the energy of the signal, and this is the real output received at the output. Exactly. I hope you got my point. So we plot with this how exactly the process goes with the help of Euclidean technology, Euclidean spaces pi 2 and pi 1 here. Exact. Sorry, this pi 1. I am wrote it pi 2. Okay, pi 1 and pi 2 here. Okay, exactly. So that means whatever the received expected information, at the output, it must, at the input of the receiver, should be the summation of the input plus noise receiver. The input noise is equal to somewhere around in this point of this Ellison, this noise cloud. This noise cloud has to be somewhere, this receiver will be point of this, and the input is this, exactly goes here. This is the input, and when you take up the point, we'll get back to observation vector. This is the real input, and this energy is the real signal of the received that. Okay, so when you, with respect to, when you consider the capital X, if you say exactly capital X is equal to x1 and x2 x3, and this is what exactly, look back here. So that means we can certainly say that the maximum condition, okay, exactly this is the absolutely, so this I have mentioned it already. This is one of the point is exactly, this is exactly the received point. This is okay. When you are taking the example of this point, this is, let us observation point. Let me, the probability density function is exactly P naught expected, because output is also depends upon this. This as for the optimum rule. See, one very important, probability of not happening here. Look here. See, we have seen that probability is not happening is equal to 1 minus of probability happening. So probability of not happening is absolutely, probability is happening is equal to not happening is equal to 1 minus probability is not happening. With this, by using optimum, see, this is all equation which you have to understand. This is absolutely, equation has to be matched with optimum decision rule, which has been specified this. In order to maximally decode it, that it has to obey this PI. This is exactly the rule. This is the condition. PI of M I have said. This is the condition has to be met in order to get maximum likely code. This is exactly the equation. This, the decision rule is called as a posterior probability rule, we call it as a MAP. The system which adopts MP rule, we call it as maximum post recall. And this is exactly the condition is given by, just it is all equation. I'm just telling nothing more than that. Maximum likelihood is the function which is absolutely what is exactly the maximum coding of the information is perfect or not. That is maximally probability density function will give. That is exactly the maximum likelihood code which will be analyzed with the help of the what exactly probability function. As you know that x of t is equal to probability noise is 0. The probability is not happening of this is actually 1 minus of this is given by this, and in order to optimum decision rule of the statistics, you actually get the sending of the information should be greater than probability is not happening. Probability happening, probability not happening here is given by this point of view. Okay, exactly. If this is the condition is satisfied, the probability density function is satisfied this condition. We exactly call posterior probability map, and the rules which the system which adopts the map rule we call it as maximum posterior decoder. By ignoring the probabilities, we have map rule is given by this pi of x is equal to this. Okay, this is pi of x. Okay, exactly this much. Okay. And this is the condition. So what we can say, as per the point of the likelihood function at the receiver, maximum L of MI is equal to the optimum decision rule. If the above equation satisfy that the probability density function, which is the output, will be coded. If satisfy that rules and regulation optimum decision, we call it as a maximum likelihood rule. Please understand your mathematics. So just mathematics equation, you have to understand the concept of that, and how is that receiver has to be interpreted with respect to our maximum finding of the information is perfect. We call it as a maximum. It is only obey with optimum decision rule as per the equation given by the probability statistic by using the probability happening or not, because probability happening and probability not happening is equal to 1 as a summation. So probability happening is equal to 1 minus probability not happening. Substitute the equation with the alpha of, and you will get back to that. Okay, next let's go back. See, this is the what exactly this correlation. How exactly the receivers. The receiver will consist of decoder and maximum likely decoder here exactly. So decoder is a part here like x of t comes here. Each one will multiply what exactly bias function. Each multiply over the integrated var. We will get back to what x1 x2. Okay. See, this x1 will absolutely, this is called as observation vector. This is real input of the receiver. Okay, x of t is each x1 will come and multiplies to this, and one of the value will become 1. Likewise, as x1 x of t is equal to x1 2 x of 2 x2 3 x4 come, each one will multiply. One of these output will become, and it will be coded as an observation factor. This is exactly called deductors. The second is what exactly maximum likelihood decoder. This is deductor is how exactly detects the input. at the receiver point, which is absolutely observation. Each point, let us say x of t is equal to x1 of 2, x of 2, x of 3, which will come. Each one will go to some of the what you call multiplier with some basis function. One of the basis function will become 1, and according to the output is becomes 1. Likewise, for each x of 1 to x2, 3 up to x of I of t, I is equal to 1 up to the m, one of the output will become 1, which we can code it as like this. We call it x1, x2, x3, 4. Okay, exactly. Now let us come to the maximum likelihood decoder. What is exactly the maximum likelihood decoder? Here, look back here. The maximum likelihood decoder, decoder operates on the how this will be decoded. It will estimate the information, because look back, this is observation, and as we mentioned that observation has to be what? Input plus noise, input plus noise. Input is equal to SI of t plus noise. SI of t plus noise is equal to 0. The maximum likelihood decoder operates in the observation vector to produce the estimate of the transmitted signal. Okay, exactly. Here, like this is the one. How exactly? It will be this, as you know, each one will become multiplied to this one. Each one will be, each x of n will be multiplied to the accumulator. Accumulator will give x of t. This is where we are going to plot. That means in this point, at this accumulator, it will point the what? Elicited signal will get back to x of t, x of this. Then this may not be equal, so we are going to multiply it with what exactly? Energy. Here, likewise, each x1 bit will come and multiply. We will get back to so many x1 of 2, x of 3. Is one of the best will be, one of the largest will be selected. That is exactly, we call it as select large. Okay, that is exactly maximum likelihood decoder. I hope you understand this much. Very simple, nothing more than that. Okay, next let's come back to the what do you call it? Another one is matching. What do you call it as? What do you call it as? Matched filter receiver. Okay, exactly. We call it as match receiver filter is the one. Look back here. In these cases, we need so much correlator. We call it as correlator multiplied summation. Correlator and summation in this equation. Okay, exactly. This is, look back here, for a jth output require jth correlator, jth multiplier, and that means as the input number of bits exceed, we'll get back to so many things. Then this, so that means hardware is also get exceeded, and along with that, the speed of the execution will also become very less. Okay. That means instead of that, we using that, what we are going to do, with the help of the what? Linear time varying. Instead of using all X correlators, instead of that, I can use LTI with the help of the impulsive response, so that as I know the impulsive response, by using convolution property of the LTI, we'll get back to this x of t is equal to h of t minus t, tau is equal to this equation. Okay, exactly. This is LTI with this. So look back here. Then y of t is equal to, that means y of t is equal to what? X of t. X of t is equal to input to the receiver here. Just assuming this LTI itself is the receiver, and this equation, look back, this equation and this equation are the same, because output has to be concerned with what exactly? Output of the receiver we have taken into what? Bias function. This equation, this one, when you compare these two equations, this output of this real has to be equal to this, because this is an LTI system. We are equating the receiver, but we are determined with the help of this geometrical signal distribution that the output of the what you call receiver has to be concerned with what exactly? Bias function. So for the x of g should be equal to what? Y of j. This is equal, when you're comparing the corresponding term, I will get back h of this phi j. That means that the condition required for consider LTI impulse response is to represent, that means if you use the LTI system as a receiver, okay, receiver exactly, it should be matched with this condition. Then we can say that can be utilized for what exactly? A receiver point of view in our ADW and column, since it matches with the condition what exactly. If you wanted to use LTI system as a receiver in ADW, that should be matched. That is exactly, that should be matched with what exactly? H of t minus tau is equal to what? Pi of j, and that is why we call it as a matched filter. That's for the matched filter can be utilized absolutely in our match in receiver can be utilized in our AW as a receiver point of view. Okay, so this is what exactly how you can able to received signal, how able to pi of 1 t minus 2 t, this all the things, and these are the signals sample at t observation vector. Look back here, receiver, pi of each function of the received signal x of 1 is multiplied by this, and one of the signal is guessed and will get with exponent x. The same match filter is need in the receiver for detecting estimating the signal in AWS. It is called as a match filter. Okay, so what is exactly the match filter? Because it has to overcome the hardware deficiency, more hardware are not the deficiency, more hardware in the what exactly the receiver correlation output, because it requires a more number of summation, more number of correlated output, which has to be what exactly more correlator output and all the fact. In order to remove that fact, what we are considered, we are taken as a linear time invariant system as the receiver point of view that can be utilized as a receiver in AWS if and only if it matches. H of t is equal to bias function of the receiver, which is locally generated by the receiver in order to detecting the information receiver is correct. That is x of t is equal to what? Input plus output, that is equal to what? Probability density function, absolute. That way we call it as what we call match filters. I hope you understand. Correlation receiver, optimum receiver should be consist of what? Good detector. Second thing, what? Maximum likelihood receiver. The maximum likelihood receiver will be consist of what exactly? Look back, I just mentioned. This is exactly the match filter, and this is the maximum likelihood receiver. Where exactly here? Maximum likelihood decoder. Decoder means it decodes the information. And look back here, when you come back to the detector, this is simple as that it produces each one will be in observation vector, and likelihood detector will find out which one, what is the valid detector with the help of the received spaces at this point. And match filter will be what I call it as match filter receiver will be used as the LTA system for in order to identify the, in order to decode or identify or decoding or estimating the information is correct. That's kind of your second unit. Okay. So as please follow as per direction, mail will be sent to you.